In question 28, we're given the following information that we have 1 pound of nitroglycerin and it explodes following the reaction outlined below. That temperature occurs at 750 degrees Celsius and 7.5 atm. Given that information, what volume in liters is produced by that explosion? So this is very similar to some of the calculations we looked at in class, with the exception of here, there are multiple products in the gas phase. So first steps first, we need to find the moles of nitroglycerin given the gas. So we're given that we have 1 pound of nitroglycerin, and we know that in 1 pound we have 454 grams. So I have 454 grams of nitroglycerin. Now I can find moles of nitroglycerin. We know that nitroglycerin is 227 grams per 1 mole. That's the molar mass of nitroglycerin. So 454 divided by 227.08, and we get very close to 2 moles of nitroglycerin. Now to find out the moles of gas that's produced in the reaction, we need to go to the balanced chemical equation and look at the coefficients to tell us the total number of moles. And so the balanced equation says for every 4 moles of nitroglycerin that reacts, I'm going to produce 12 moles of carbon dioxide, 10 moles of water, 6 moles of nitrogen, and 1 mole of oxygen. So the total number of moles that are produced in this reaction that are in the gas phase is 10 plus 12 plus 6 plus 1. So that gives us 22, 28, right? 29 moles of gas are made in this reaction. And we can use PV equals nRT and the total number of moles, because the total number of moles is also related to the total pressure of this. So we can combine all of those moles of a gas because they're all at the same temperature and pressure. So PV equals nRT applies to the total number of moles. So I put in 2 moles of nitroglycerin, and the balanced equation tells me for every 4 moles of nitroglycerin, I'm going to produce 29 moles of a gas. So essentially I'm dividing 29 by 2 to get 14.5 moles of gas. Now we can find the total volume because I have moles of gas. So PV equals N, R, and T, and we're looking for volume. So I'm going to divide pressure across to see that volume equals N RT over P. So the volume of gas that's created, the number of moles, 14.5 moles, 0.0821 liters ATM mole Kelvin is our gas constant. We need to find our temperature, and the pressure is 7.5 atm. For our temperature, the temperature of this reaction is 750 degrees Celsius, so Kelvin equals 750 plus 273. So the temperature in Kelvin for this reaction is 1023 Kelvin. So multiply across the top, moles cancel out, Kelvin cancels out. When I divide, atmospheres will cancel out, and that's good because we're looking for a volume, and volume should be in liters. So the volume of gas that's going to be produced in this reaction, so times 0.0821 times 14.5, and then divide that by 7.5 atm. I get approximately 162.4 liters of gas produced in this reaction. So to 3 significant figures, I would say the volume equals 1.62 e to the 2 liters in this reaction. The trick to this problem being that we had to use all of those moles of gas, and knowing Avogadro's law, we know we can relate the total number of moles of gas to the volume of that gas because they're at the same temperature and pressure in this question.